Hello everyone, I'm Aaron Dahlin. In this video, we're going to explore how to use the user-defined function block using structured text to convert a type real to a string which you can then use to display on your Allen Bradley Micro810. Here's our connected components code. We're going to start out in ladder logic, and then we're going to transition into a user-defined function block featuring structured text. On this top level, we start with a time on counter that produces a Boolean pulse per second. That pulse per second is then used to command the LCD to update once per second. For example, here on line 2, we clear the LCD buffers. That's string LCD buffer line 1, line 2, line 3 and 4 off to the side. On rung 3, we add the text machine status. Rung 4 is our user-defined function block that converts a type long real to a string. We'll explore that in a moment. And finally, on the last rung, we have this LCD block which takes the 4 line buffers and sends them to the LCD. This is our user-defined function block of interest. You'll notice that it takes in a global long real. Here we specify the number of decimal digits we're going to use. For example, in this case, we have 48.83. So we desire to have 2 decimal digits. All right, so that's what this input does. The pre-string, we prepend some text in front of the number. So that's this part right here. So TEMP equals, okay, that's to be prepended before the number. And then we have this part here, which is appended. So in the end, we'll end up with a string that says TEMP space equals space 48.33, and then we append an F to it. And that is the string that is sent to the LCD display. And it's done through this LCD line buffer, which we see right there. To get started with this user-defined function block, we come over to this section here where we see user-defined function blocks, and we right-click and go to parameters. Again, this is the parameters screen. To the left are the inputs, and to the right, the outputs. These things in the middle are the variables that are used to make the program operate. You'll recall that we hung this particular user-defined function block on the ladder diagram with Boolean enable and Boolean enable out, like so. And then you have the various parameters on the left and the outputs on the right. They go in the order you see them here. The first one, again, being enable. From there, we have the long real input number. That's the number that's going to be converted. For example, that might be 48.24374. Again, these numbers aren't real out here, but we'll include them anyway. Here, we describe the number of decimal digits to be included. So maybe you only accept 2. Here's the prepend, and then this is the piece we want to put after the string. So if we wanted to say temperature is equal to 48.24, and then put an F behind it. This is the pre, so we'll prepend that, and this is the post. To see this user-defined function block, we click here. The block starts with a header, a brief description of what it does, followed by a brief description of the inputs, the outputs, and then the body of the user-defined function block itself. Line 26 is the first real line of code. What it does is copies the contents of enable in and transfers it to enable out. So if the enable in line is active, the enable out line will be active. The next group of code here says if it's enabled, we continue. If it's not enabled, right, if not Boolean enable, then we return. That keyword there means we're done with the user-defined function block. It exits at this point without touching anything else. If we are enabled, then we continue on. On line 32, we clear the contents of the output string. These next two lines add the prepend string. Remember that our output string could be thought of as an array of characters, right? That's this one right here, our string out. So again, if you think of it as an array of characters, what this line right here, 35 and 36, do is add the characters. So our prepend, T, E, M, P, space, equals, space. So maybe that's what we added. One of the things that it does is it keeps track of a pointer, so an integer string pointer, which will point right here. It'll point to the next available character. That way, as we continue on with the code this way, we know that the next available character is right here. And that's important because you don't know beforehand what the length of our prepend string is going to be. It could be very short. In fact, it could be non-existent, and this code would still function. Line 37 is important to us because this is the first time we look at the long real number that's to be converted. Now, when we're dealing with structured text, when you pass a variable to a user-defined function block, you could think of it as a constant, which is to say you can't modify it. So you make a copy of it. In this case, we're going to take our input number and we're going to put it into a variable, a local variable called long real num. And then we're going to modify that as we move through the code here. These next few lines look at the contents of our long real number. Again, that's the local buffer. And it asks, is it less than 0? Or is it negative? If it is, it's going to add a negative character to our string. So T, E, M, P equals space equals, and if I look at the local temperature right now, we are at negative 16 degrees Fahrenheit. So right here, that's where it puts this negative sign. It also increments the pointer. So we got a little ahead of ourselves. That pointer is now located right here, pointing to the next available block. Okay, so that's integer string pointer is equal to integer string pointer plus 1. Lines 53 to 62 determine the size of the whole number. If you had a number such as 1, 2, 3, 4, decimal 1, 2, 3, it would look at this part right here. So in this particular case, we have a whole number with a size of 4 decimal digits. It features a for loop, which will iterate no more than 20 times. Now, you certainly could have used a while loop in this application. However, I don't like the errors that Connected Components throws when you use while loops, because it always reminds you that a while loop could hang the PLC. So we'll go with the for loop. As we go through this for loop, there's a couple of things to watch out for. One is this long real place variable, and the other is the integer index. The way this works is we take our long real number. Remember, that's the thing that we copied the input into, and we divide it by the places. We hold that value in this long real scratch, and then we ask ourselves a question: is long real scratch less than 1? Let me give you an example of how that works. Back to our input of 1234.123. The first time through the loop, our long real place is going to have a value of 1. So we're going to divide this number by 1, giving a result of 1234.123. We're going to compare that to 1. If this number is less than 1, then we exit. If it's not, then we multiply places by 10 and we go through the loop again. Dividing this time by 100, giving us 1.234, so on and so forth. That still doesn't reach our termination. So once again, we multiply places by 10, which gives us 1,000. Still not there, because that gives us 1.234 and change. So one more time, and when we divide it by 10,000, we finally reach a point where this value, after the division, right, this value right here, is indeed less than 1. And when that happens, we fall into this code here. You could think of this as the "you've gone too far." So now we're going to take that 10,000, we're going to convert it back into 1,000, and we're going to subtract 1 off our index in preparation to do the next chunk of code. As we enter line 65, we have a couple of things. We have our long real number. In this case, we'll do an example, 1234.123. We have the place value, which is holding a value of 1,000. And we also have an index. And that index is going to tell us how many times to iterate through this loop here. And for this particular example, we're going to iterate 4 times. Our opening move is to perform a division. We divide our number by the places, which gives us a value of 1.234123. This leading digit here is the most important. It's the thing that we need to isolate and put into our string. TEMP. So we've loaded that up already. That was the prepend string. And now we want to put a 1 right here. In order to isolate the whole from the fractional, we do a any to long integer conversion, which is really just a fancy way, or a not so fancy way, of doing a floor operation. So we're going to round to the floor, which means all of this just gets dropped, and we're left with a 1. We run that through an any to a string, hold it in string buffer, and then we insert string buffer into our string at the value specified by our string pointer, which previously was pointing right here. Our next step is to move the string pointer so that it points to the next available digit. And then we have to prepare our number for the next round. So come back here and subtract off 1,000, leaving us with 234.123. That operation is performed here. What we do is we take our long integer scratch and we multiply it by our places. So previously, long integer scratch held a value of 1. We multiplied it by 1,000, and then we subtracted on this line right here, which gives us a number of 234.123. From there, we modify places, so we're ready to go for the next iteration. If you follow through this loop on the second iteration, you'll see that it develops the number 200, which is subtracted off to give us 34.123. And on the next iteration, of course, we're going to subtract off 30, and so on, till we get to the point where we've gone through all of the digits in our whole number. And those get deposited right here, with our pointer being incremented to the next available digit. I almost forgot to mention this code right here, which adds commas for larger numbers. So what really would have happened is temp equals space equals 1 comma 2 3 4. And we are right here pointing to the next available number. Line 86 asks the question, how many decimal numbers do you want to include? If the answer is 0, we're basically done. If it's not 0, we're going to add the decimal point here and advance our pointer, right, our string pointer, to the next available slot. Okay, we're almost done with this function block. Remember, when we started out, we had the number 1,234.123, and we've been modifying this number, and every time we've gone through the loop, we've effectively dealt with the leading digit and then subtracted off. So we subtracted off 1,000, we subtracted off 200, we subtracted off 30, we subtracted off 4. So at this point, we are left with 0.123. Again, that is what is held in this long real num variable. On line 92 through 94, we look at the number of decimal digits that are desired. In our example, we assumed that was 2, and then we're going to multiply this number by that many places. So we're going to multiply by 2 to give us 12.3. And now we're going to use the exact same code over again to produce the numbers 1 and 2 here, with our pointer pointing to the next available digits. I'll leave that to you. I'm just going to make a note here that this block uses the same code as was used up here. So that just made it a little easier. We didn't have to reinvent the wheel. Again, that's the same routine we used for the whole numbers. We iterate through this loop, capturing our decimal numbers. TEMP equals 1, 2, 3, 4.1, 2. And we are pointing to this next available digit here. The last step is here, where we add a space. So we add a space, moving the pointer to here. And then we add our post string, which was F in our example. And that brings us to the end of the user-defined function block. As we end, let's take one last look at the parameters. The first parameter is enable, and that is copied or transferred into enable out. If we are enabled, the block operates. If not, it does nothing. Long real in is the number that we wish to convert from a type real to type string. Integer number of decimal digits tells us how many decimal digits to include. Prepend string and a postpend string. Of course, string out is the character buffer that we send on, in our case, to the LCD to be displayed. Inside are the various variables that we used. Integer index was very important to us because that told us how many times to iterate through the various loops. Long real place, that was also very important to us because it told us which decimal digit we were working on. This integer string pointer was very important because that was how we knew where to insert the various things into our output string. And this long real number was something that we copied our long real input into, because connected components deals with these input parameters as if they were type constant. And the last thing is the instantiation. So we go to our program control, and here is an instantiation of our function block long real to string. There's the enable line. Here is the type long real that is to be converted, the number of decimal digits, the pre and the post strings. When all is said and done, we're able to display this on our front panel of our Micro810.